Okay, independent events, or rather dependent events on page 135. We're moving on to that. That's section 9.4, playing with A stroke A star. And it says here that events are dependent if the outcome of one event affects the outcome of the other event. This is also known as conditional probability. So we have something happening, we have a probability of that happening, but if such and such happens, then something else is affected further down the line that will impact its probability. And so the two probabilities are not independent but rather dependent or conditional. So if I look at page 135, question 2, we can illustrate what this means. There are certain conditions whereby question 2 illustrates the dependent nature of some of these events. So question 2, page 135. A bag contains 10 counters. Let's click on the pen. So I've got 10 counters. I've got 6 black and I've got 4 white. Alright, 6 black, 4 white. 2 counters are chosen at random without replacement. This is the tricky part. No replacement allowed. Draw a tree diagram and use it to work out these probabilities. Okay, so here I go. First go, I can take out a black counter or a white counter. Clearly so. Second time, I can take a black or a white. Similarly, black and white. So these are the different events. Black, 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 white, white, black, or white, white. Now, get the probabilities in place. If I take out a black counter, the probability of getting that first go will be 6 over 10. And the probability of getting the white will be 4 over 10. Well, that's easy so far. If I've taken out one black counter, I've got one black counter less. So that's 5 out of the remaining 9 counters, you see. So the fact I've removed this first black counter has affected the probability of getting the remaining black counters, because I'm now down to 9 and I've got one less. So the whites have not been affected. I've still got 4 whites left out of the 9. Or if I take a white first, I've still got my 6 black ones out of the remaining 9. If I take one white out of the 4, I've got 3 left out of the remaining 9. And that's the tree diagram, and that's sort of basic grade A. Now let's just work out the two probabilities for each branch. So probability of going black followed by black is going to be 6/10 and 5/9. That's going to be 30 over 90. Let's not simplify it just yet. Maybe helpful not to do that. Probability of going black and then picking up a white is going to be 6/10 followed by 4/9. That's going to give us 24 over 90. Then white first, then black. Probability of white, then black. That's going to be 4/10 followed by 6/9. So we've not taken the black one out yet. Still 24 over 90. And last of all, probability of getting a white counter followed by a white counter, you're looking at 4/10 and the remaining 3 out of 9. So that would give us 12 over 90. Right, let's leave it all out of 90. We can simplify at the end if we want to. Now, use your tree diagram to work out the probability that both counters are black. Well, the probability that both counters are black is that one right there, so we can call that a third. Alright? Black, black, bang, bang, 1/3. What is the probability that both counters are white? Well, that's this one just here, white followed by white. 12 out of 90. Let me simplify that quickly. 12, ABC 90, ABC button, 2/15. I'm not sure if we need to do that really, but let's do it while we can, because we have a calculator in this unit. And then it says, what is the probability that one counter is red and the other is, sorry, wrong colour. What is the probability that there are different colours? Okay, so in other words, I want a black white or a white black. So here I go. I've got this or that. Okay, so because I want one or the other, I add the two probabilities. Gives us 48 over 90, and I will now simplify that using my ABC button. So 48 ABC button 90, and that will simplify it nicely for us. 8/15. Alright, and that's the first sample of grade A tree diagrams with dependence events. That's question 2. Let's move over. We'll do one more and we'll keep the video short, I think. So question 3 I wanted to do next. Right, this is the one my eye skipped onto accidentally while I was doing the previous question. Right, a box contains 3 red pencils. Let's write it down. So I've got 3 reds and I've got 8 blue pencils. Alright. 2 pencils are taken at random from the box and they're not going to be replaced as is usual. Draw me a tree diagram and then do something special with it. Okay, so what can I do? I can take out a red pencil, a blue pencil for the first go. I can go red and red or red and blue. I can go blue and red or blue and blue. Let's put the probabilities on there in yellow this time. What's the probability of getting a red one? Well, it's going to be 3 out of 11. Total of 11 pencils altogether there. And therefore 8 out of 11 will be the blues. Okay, that's easy. If I take out a single red one, I've got 2 left out of the remaining 10. The blues are still intact with 8 out of 10. If I take out a blue first and then a red, the red's not been taken out yet, so it's 3 out of 10. And a blue's already disappeared at the second level, so I've got 7 of them left out of 10. Please note, these probabilities add up to 1, 11 over 11. These probabilities add up to 1, 10 over 10. And these probabilities add up to 1, 10 over 10. So I know I've got my probabilities right. So without even having to read the question, let's just work out some probabilities and then relate them to the question later on. So red followed by red, 3/11 multiplied by 2/10, 6 lots of 110. Probability of going red followed by blue is going to be 3/11 multiplied by 8/10. That's going to be 24 over 110. Next one, probability of going blue followed by red is going to be 8/11 multiplied that by your 3/10. 24 over 110. Last of all, probability of going blue pen followed by blue pen, or is it pencil? I can't remember. Yeah, pencil is going to be 8/11 multiplied by 7/10. 8 7s 56. 56 over 110. So that's all the tree diagram and the various probabilities that ensue from that. Now let's look at the question. Let's change to red so it stands out. Okay. Use your tree to find the probability that both pencils are red. Well, that's red followed by red, so it's 6/10. I'll have that one. Simplify it down using my ABC button. 6 ABC 110. I've just got 3/55. That's that one done. What's the probability that both are green? I think that is a misprint in the book. Many of the students have gave that as an answer as 0. I think they mean both are in fact blue, so I'm going to assume that's what it's meant to be. So blue followed by blue is that one, which is 56 over 110. So 56 ABC button 110. That simplifies down to 28 over 55. Not very exciting, is it? Doesn't go any further than that, so I have to live with it. And finally, that one pencil is red and the other is green. They've done it again. I think they mean one is red and the other is blue. That's what I'm going to assume anyway. So we take these two. Red, blue, or blue, red is what's required. So we've got 24 100 over 110 plus another 24 over 110 gives us 48 over 110, which I will now simplify. 48 over 110, that gives us, do that again, 48 ABC button 110 gives us 24 over 55, and that is it. Right, we'll give that a little pause before we move on to some really challenging questions, and that's it. So you study that carefully, lots of little fractions. Again, you've got calculator, why you can still use it, so use it, and that's all there is to it. Thank you.